SCT, studying in Sayadri College of Engineering and Management and Mechanical Department. I am here to present a seminar topic on underwater welding under the guidance of Mr. Prakash Kumar Kaur sir, Assistant Professor, Department of Mechanical Engineering, Sayadri College. So now let's discuss. Welding is a process of joining metal by heating the surface by striking an electric arc with or without application of pressure. Now, what is underwater welding? The welding process, it's the same thing, but if it's done under the water level, then it's called underwater welding. This is the actual picture of underwater welding. And now let's see the table of contents. Introduction, requirements of underwater welding, types of underwater welding, then advantages, disadvantages, risk for welders, and features. Introduction to underwater welding. As said in the beginning, the underwater welding is a process of welding at elevated pressures, normally underwater. The underwater welding can either take place in wet water itself or dry inside a specially constructed positive pressure enclosure and hence a dry environment. Why is underwater welding required? As you can see in this picture, there is a red mark there. If you want to do the welding process, if you want to join that part, you need to lift the part and then do it. Which is very difficult task. So underwater welding is preferred in this. And you can see one more picture there under the ship. If you want to weld this part, so you need to lift the whole ship. Instead of that, we can do underwater welding. Okay, now types of underwater welding: wet welding and dry welding. This is wet welding and dry welding. Picture of wet and welding. Wet underwater welding directly exposes the diver electrode to the water and surrounding element. The divers usually use around 300 to 400 amps of direct current to power their electrode, and they weld using varied forms of arc welding. This practice commonly uses sheared metal arc welding, employing a waterproof electrode. This is a continuation of that. The other processes that are used to include arc welding. These are the other processes used in underwater welding: flux core arc and friction welding. In each of these cases, the welding power supply connected to the welding equipment through the cable and hoses. The process is generally limited to low carbon equivalent steel, especially at greater depth because of hydrogen cause cracking. This is a schematic diagram of underwater welding. This is a workpiece. This is a weld deposit. This is the metal droplets from the arc. This is a core wire. This is the waterproof so that it doesn't affect the core wire. This is the barrel length, gas shielded bubbles, slag, metal droplets. This is the actual picture of underwater. Advantages of wet welding: it is the cheapest process, fastest process, tensile strength is higher, ease of access to the weld spot, no wastage of time in construction of habitat. Disadvantages: rapid quenching decreases impact strength and ductility. As you know, the heated part, when you are doing in wet welding process, the part is directly exposed to water, and hence the quenching is rapid. The cooling rate is very fast, hence the ductility is increased. Hydrogen embrittlement, poor visibility in water, higher energy deposition of hydrogen, higher efficiency. Dry welding. Dry welding is considered as welding in dry ambient atmosphere where the welder is separated by mechanical barrier. The dry welding is used in preference to wet underwater welding when high quality welds are required. Dry welding can be classified of two types. One is large habitat, the other one is mini habitat. This is the large habitat. This is the mini habitat. These are the two pictures. Advantages of dry welding: welder or diver safety, good weld quality, surface monitoring. Disadvantages: higher cost of process training, etc., large quantity of costly and complex equipment, more deep, more energy requirement, can't weld if the spot is unreachable at the place. This is a schematic diagram of underwater welding. You can see the welding machine is connected The ground is connected to the work. The positive is connected to the electrode. The electrode is also connected with oxygen cylinders. Risk for welders. There is a risk to the welder of electric shock. There is a risk that defects may remain undetected. The other main area of risk is to the life or health of welder or diver from nitrogen induced in the bloodstream during the exposure of air at increased pressure. This, as you all know, this underwater considered as one among the riskiest jobs done. And what are the safety measures or precautions can be taken? Start cutting the highest point at the work downwards by withdrawing the electrode every few seconds to allow the water to enter the cut. The gas may be vented to the surface with a vent tube secured in the place from high point where the gases would collect to a position above the waterline. Precautions include achieving adequate electrical insulations of the welding equipment. What are the future scopes or developments in underwater welding process? The development of alternative welding methods like friction welding, explosive welding, and stud welding. As I said in the beginning, the underwater welding, the type of welding used is arc welding, and friction welding is recently used, so it can be developed. And one more development that can be done is Thor 1, that is TIG hyperbaric orbital robot is developed where the diver performs pipe fitting, installs the tracks and orbital head on the pipe, and rest process is automated. The welding can be done automatically in this Thor is developed. These are references I used. I took as reference to this PPT. And thank you.